Hello everyone. Today we're gonna explore about the one chapter in chemistry, which is stoichiometry. These are the learning objectives, but for today we will focus on balancing a chemical equation and calculation using stoichiometric coefficients, and also performing stoichiometric calculation involving masses, moles, volumes of gases, number of particles, and concentrations. Stoichiometry comes from the Greek words. So in etymology, it comes from two words. Stoichion means element, and metron as in measure. In chemistry, stoichiometry defined as the calculation of quantitative relationship between reactants and products in a chemical reaction. Now we will discuss about physical change and chemical change. In physical change, there is no substance form. So the original before the change, the original substance, and after the change, still the same substance. The process usually reversible. Yes, some physical change can be reversed, like melting ice. We can obtain it again by refreezing it, while the other are irreversible, like cutting wood. When we cut it into smaller pieces, we cannot obtain the original wood. But the point is, the chemical composition of that small wood and bigger wood that we cut is still the same. All change in properties, like changing in states, changing size, changing shapes, changing texture, usually belongs to physical changes. I'll give you some example. Tearing paper is counted as physical change because when we are tearing it, there are no chemical bonds breaking in that process. So basically, the paper just turned into smaller pieces. We can get the original paper by make it into pulp, and then we mix it again, and then we lay it in the sheets so we can get the original paper. Grinding process also same, it's a physical change. Cutting and also melting. Example of physical changes states such as melting, boiling, freezing, and condensation, including evaporation, including also sublimation and deposition. Change in shape or size by cutting, bending, grinding, it's counted as physical change as well. Dissolving sugar to water, it's also physical change. Change in temperature, such as heating or cooling substance, is also physical change. Please note that this heating comes from outside. So we put heating on a substance and the substance become hot without changing states. That's also count as physical changes. Mixing, combining two different substances as long as the product is a mixture, so it's counted as physical changes. And physical changes, of course, it is not a chemical reaction, which does not involve breaking or forming chemical bonds. In contrast, chemical change form a new substance. There are bond breaking and bond forming during a chemical reaction. So the bond in the reactant will be break, and they form a new bonding and then produce a product. Usually they are irreversible, but some maybe tiny parts of the chemical reaction can be reversed. There are special chapters discussing about that one. It's called equilibria or equilibrium. Sometimes chemical reaction also followed by release and absorption of energy can be observed as a temperature change or emission of light. For example, if the reaction absorbs energy, it's called endothermic reaction, and if the reaction release energy, it's called exothermic reaction. There are 5 evidence of change in chemical changes or chemical reaction. The first one is color change. Second is temperature changes. 3 is precipitate formation or solid deposition. 4 is gas formation or smell. Or we can say effervescence, we can say fizzing, but never say bubbles. 5. Release of energy in another form besides the heat, because we already mentioned heat in number 2 as a temperature change. So it could be light, sound, or maybe combination of both, so it forms explosion. It could also produce electrical current as well. Balancing chemical equation. As we know that we can write chemical equation in 2 ways. The first is by writing word equation. So let's say this example, nitrogen plus hydrogen to forms ammonia. We can write them into symbolic or chemical equation. So nitrogen plus hydrogen to form ammonia. So this is the symbols of this element and compound. But if you notice, the number of element, the left hand side means any element or substance before the arrow sign, and right hand side means any element or compound after the arrow sign. So in the left hand side there are 2 nitrogen, but on the right hand side there is only 1. And also there are 2 hydrogen in the left side, and there are 3 hydrogen on the right side. So we need to balance it. To balance chemical reaction, you cannot change the subscripts in any way, because it represents how the molecules, how the element arrange in the molecules. So you can only add coefficient in front of the element or compound, which this coefficient belongs to any element behind it. The importance of balancing is reflects the actual reaction, conserve mass and atom as part of Lavoisier's law about conservation of mass. We have correct stoichiometry, predicting the quantity so we can calculate later in the chemical reaction how much product we will get when we have the reaction. And also application maybe in industry as safety precaution, because some reaction release energy, so we can manage the amount of chemicals that react to prevent dangerous result, and also as efficiency, so we can calculate how much do we need as a raw material to produce our product. How to balance a chemical equation? I'll give you one step by step how to balance chemical equation. using a random method or trial error method. First, check number of elements on each side of a reaction, like this one, nitrogen plus hydrogen to form ammonia, and then I'll give space in front of each of the substance to put my coefficient in there. So let's check it. On the left hand side there are nitrogen, there are 2 subscript multiplied by number of atoms on there, so it's 2. Nitrogen also 2 subscript times number of element, which is 1, so equals 2. On the other side, nitrogen is 1 times 1 equals 1. Then hydrogen also 3 times 1, so there are 3. So if you notice, there are different numbers of nitrogen and hydrogen in the left and right hand side. So the thing that we can do is let's try from the most complicated first, which is NH3, and then related to H2 there are 2 and 3 in there. So what is the common multiple of 2 and 3? It is 6. So we use 6 as a common multiple, so it can balance 2 and 3. So 6, if we divide it by 3, the result is 2. So we put 2 in this and in front of NH3. So now the number of elements change on the right hand side. So nitrogen 2 times 1 times 1, so 2, and hydrogen 2 times 3 times 1, so 6. Now we see the hydrogen. Hydrogen on the right hand side is 6, and total hydrogen in the left hand side is 2. So what numbers we need to put on? So the result could be 6. There are already 2 hydrogen in there, so we need to multiply it by 3. Then we check again number of element. Untuk hydrogen we have 6 on both sides. Nitrogen also 2 on each side. It's already balanced. If we put 1 in front of N2, but you need to write coefficient if the value is 1. So the final balance is this N2 plus 3H2 to form 2NH3. So left hand side is, for nitrogen total is 2, hydrogen is 6, nitrogen is 2, hydrogen is 6. So this is the balanced chemical equation for nitrogen and hydrogen to form ammonia. I'm gonna give you another balance method to balance chemical equation. The reaction is aluminum plus chlorine to form aluminum chloride. So same as before, we check the number of element on each side. Clearly it's not balanced. So the common multiple, we can use common multiple of chlorine, which is 2 and 3, so it's 6. So we put 2 in front of AlCl3, so the number of chlorine on the right hand side change into 6, and total aluminum also change into 2. So now on the left hand side there are less chlorine, so we need to multiply it by 3 to make it 6. So now the total of chlorine is already balanced, but the aluminum atoms is not balanced. This one is easy because right hand side 2, left hand side 1, so we need to multiply it by 2 on the left hand side. So now the total of atoms is already balanced. Yeah, let's check it again. Aluminum on the left hand side 2, right hand side 2. Chlorine on the left hand side 6, right hand side 6. So it's already balanced. This is the balanced chemical equation. Okay, you may try this balancing practice. Yeah, I'll give you the answer of this practice in the description of this video. State symbol can be added to a chemical reaction to show the states of each element or each compound that reacts. There are 4 state symbols: S for solid, L for liquid, G for gas, and AQ for aqueous or dissolved in water. The details about how to assign these state symbols will be explained after we do chemical bonding chapters. Mole ratio is equivalent to coefficient ratio. Let's say we have reaction to A plus B to form A to B. So the ratio would be 2:1:1. So previously we learned about ratio, but in the form of mass ratio, law of proportion by Proust. So now, because it is not convenient using ratio of mass every time we change the chemical reaction, so we just follow the Avogadro's concept by using mole. So just balance the chemical reaction, we can directly have ratio of mole. So we can say that in here 2 moles of A react exactly with 1 mole B to form 1 mole A to B. And also we can say the ratio of coefficient A over B equals to mole A over mole B. Let's bring it to real equation context. Yeah, we have a balanced chemical equation between hydrogen and oxygen. So 2H2 plus O2 to form 2H2O. In this one, we can say that 2 moles of H2 react exactly with 1 mole of O2 to form 2 mole of H2O. Or we can say coefficient of H2 over coefficient of O2 equals to mole H2 over mole of O2. Okay, how many moles of O2 to react exactly with 5 mole of H2? We just need to change or rearrange the equation above to find mole of O2. So it should be mole O2 equals to coefficient O2 over H2 times mole of H2, because mole of H2 is already given, so we can calculate. So 1 over 2 times 5 mole equals to 2.5 mole. Yeah, in general, so coefficient of substance given divided by coefficient of substance being asked equal to mole of substance given in the question and over mole substance being asked. So if you reformat the equation, could be like this. So mole of substance being asked equals to coefficient substance being asked over coefficient substance given times mole of substance given. How to get mole from the coefficient from the question? If the sample is solid, they always give you the mass in the question. So by using molar mass, you can get the mole. Then If it is solution, they will give you concentration and volume. So you can calculate it by multiplying them to find mole. 3. Volume of gas at STP. You can always get the mole by divided by STP volume, which is 22.7 decimeter cube per mole. And if they give you numbers, either atoms, molecule, particles, or ions, you can divide by each Avogadro's constant, yeah, so you can get the mole. I'm gonna show you how to solve the stoichiometry question by this step-by-step solution, especially for type 1 question. The first one, type 1, only one data given in a question, and you need to find the other one. Sometimes only one reactant or one product, and then you need to find another reactant or another product. The first one, you need to construct and balance a chemical equation. Always check if it is already given a chemical equation. Make sure it is already balanced or not. 2. Find any data from the question that could be converted to mole. Find mole of the substance from given data, and find mole of substance being asked by using coefficient ratio. Then find the quantity being asked, usually mass, gas STP volume, concentration, or numbers, includes atoms, molecules, ions, or particles. These are the example of type 1 stoichiometry question. Let's say you have 13.57 grams aluminum, atomic mass 26.98 gram per mole, are reacted with chlorine at STP. How many volume of chlorine are needed? It's already given the atomic mass of chlorine, which is 35.45 gram per mole. So when we read this data, when we read this question, it's clear that there are one data, which is the mass of aluminum. So first we construct the chemical equation. First, Al plus Cl2 to forms AlCl3. It is unbalanced, so we need to balance it first. So this is the balanced one, 2Al plus 3Cl2 to forms 2AlCl3. Then from the data we got 13.57, so we can calculate the mole by dividing it by atomic mass of aluminum. So we will get 0.5 mole. Then we compare, because the question is asking about the volume of chlorine, so we need to find the mole of chlorine, which is by coefficient ratio between Al and chlorine. So mole of chlorine is coefficient chlorine divided by coefficient Al times mole Al. So 3/2 times 0.5 mole, so it's 0.75 mole. Then we find the volume of chlorine by multiplying by its molar volume, or STP molar volume. So 0.75 moles times 22.7 decimeter cube per mole. So you will get 17.13 decimeter cube. Alright, this is the type 2 question, step-by-step solution. In this type 2 question, there will be two reactant data given in the reaction. So you need to find the limiting reactant first as your basic of calculation. First, construct and balance chemical equation. Find any data from the question that could be converted to mole, usually to the data of reactants, and find mole of each reactant from the given data. We need to, step 4, divide the mole of each reactant by its coefficient. The smallest value of this operation will be the limiting reactant. And then use the ice chart to find each mole at the end of the reaction. Use coefficient ratio, mole ratio to find change part. And then find the quantity being asked. For example, either excess reactant, limiting reactant needed, or the amount of product, including mass, gas STV volume, concentration, or numbers, or atoms, molecules, ions, and particles. Okay, I'll give you the example of type 2 stoichiometry question. Let's say I have 36.47 grams of magnesium, atomic mass 24.31 gram per mole, are burned with 23.4 decimeter cube of oxygen at STP. How many grams of magnesium oxide will be produced? Oxygen atomic mass would be 16.00 gram per mole. So, like the first one, we need to construct the chemical equation. Here, Mg is burned with oxygen to form magnesium oxide. So, Mg plus O2 to form MgO. This is still unbalanced. And then we balance it. Yeah, so the balanced chemical equation would be 2Mg plus O2 to form 2MgO. Then, take a look at the question. There are two data of reactant that could lead to mole. We can calculate mole from that data. So for Mg, because it is solid, we can divide by its molar mass to get mole. And then for oxygen, because it is gas, volume of gas at STP, we can just divide 23.4 decimeter cube over 22.7. So we can get 1.03 mole. If we see only the mole, yeah, it looks like that oxygen has less amount of mole. But remember, Mg has two coefficient, while oxygen has one as a coefficient. So we need to divide each mole by its coefficient. Okay, to find the limiting reactant, we need to divide mole by its coefficient. So for magnesium, 1.5 divided by 2 equals to 0.75. And for oxygen, 1.03 divided by 1, so it's still 103. So the value of magnesium is smaller. So in this reaction, magnesium is the limiting reactant. And then we can construct the ice chart. First, we construct the chemical equation. And then for initial, you just put the original data. For this one, we need to put the mole value as it is. Yeah, so 1.5 moles of Mg and 1.03 moles of O2 and 0 moles of magnesium oxide or MgO. And then during the change, because magnesium is a limiting reactant, so it will be used up, so minus the same amount, which is minus 1.5. And then we can calculate the amount of oxygen reacted by using the mole ratio, which is 1/2 times 1.5, so which is 0.75. And then I put minus because it is reactant. And then for MgO, the same thing, use the mole ratio 2/2 times 1.5, which is 1.5. And then we can add them together, and then we can have 0 magnesium, yeah, because it is used up as it is a limiting reactant. And then there will be remains of 0.28 oxygen, yeah, and 1.5 of MgO formed during the reaction. So because the question is about magnesium oxide, we take this value of mole of magnesium oxide, which is 1.5 moles. Then final answer, mole of magnesium oxide is 0.5 mole. The MR or MgO is 24.31 plus 16, so it's 40.31. The molar mass is 40.31 gram per mole, and then mass of magnesium oxide would be N times molar mass, so it's 1.5 mole times 40.31 gram per mole. So the mass of magnesium oxide would be 60.47 gram. Alright, you can find more about the question in another slide, and also the link that I provided in the description. Thank you very much.